Next we have the real constants, in which we have two forms. One is the fractional form and the exponential form. So when you see the rules for fractional form, real constants, it must have at least one digit, must have a decimal point, it could be either positive or negative, and the default sign is positive. No commas or blanks are allowed within the constant. So examples are given below. The exponential form of the real constants are represented as two parts separated by the letter E. The part appearing before E is called mantissa, whereas the part following E is called as exponent. So the part appearing before E is called as mantissa, and the part appearing after E is called as the exponent. So we also have some rules for this exponential form. So both the parts should have at least one digit, that is before the E and after the E. And mantissa can be a real constant in fractional form. Exponent can only be integers. Both parts have a positive or negative sign. The default sign of both parts is positive. The range of real constants expressed in exponential form is in the range given here, that is minus 3.4 E38 to 3.4 E38. So the following are the examples given at the end of the slide. And how to form a character constant. So a character constant is a single alphabet, a single digit, or a single special character or a symbol enclosed within single inverted commas. The maximum length of character constant can be only one character. So what are the types of C variables we have? So variable names are names given to locations in memory. So why we actually name a memory? It is easy for our reference. So we don't understand the memory addressing which is being followed by the hardware. So we go in for a name that might be whatever name we like, we can have it, and we can reference the values that are being stored in the memory. Locations can contain integer, real, or character constants. In any language, the types of variables supported depend on the types of constants that it can handle. Because a particular type of variable can hold only same type of constant. So integer variable can hold integer constant, real variable can hold only real constant, and a character variable can hold only the character constant. So how do you construct a variable? So it's a combination of 1 to 31 alphabets, that is digits or underscores. So some compilers even allow up to 240 characters, but it's very safe to have only 31 characters. There are only 31 allowed characters. So first character must be an alphabet or an underscore. Other things are not allowed. So no commas or blanks are allowed. No special symbol other than the underscore is allowed. So what are the data types that we have in C? So basic arithmetic types are further classified into integer types and floating types. We have enumerated types, that is arithmetic types that are used to define variables that can be assigned only certain discrete integer values throughout the program. So it is like a fixed value which you can have throughout the program. For example, we have days in a week, that is from Sunday to the Monday. Okay, so there are only 7 days, so that is fixed. And we have the type y which indicates no values available. And we have the derived types that include the pointer types, array types, structure types, unit types, and the function types. So in integer types we have character, unsigned character, signed character, integer, unsigned integer, short, unsigned short, long, and unsigned long. So we can view all the storage size here along with the range. And here we have the floating point types. We have the float, we have the double, we have the long double. So the storage size is given along with the range and the precision. So these are the keywords that we use in C. So these keywords cannot be used as a variable name. So care should be taken such that this particular keywords are not used as variables. So the compiler vendors like Microsoft and Golang provide their own keywords. So if you see the first variable name, it is valid. Second one, it is valid. Third one is not valid because the hyphen is not a part of the cloud special symbol. This one, hash, is not a allowed symbol. Again, the next one, group, the dot is not allowed, and a variable name cannot be entirely digits. Again, this is invalid. Again, this is invalid. We have space in between. This is also invalid because it is a keyword, and only the last one is valid. So we need to see the basic operation, that is basic IO operations in C. So we need to get the input by means of scanf, and the output is going to be printed out by means of the printer. So input is got through the function scanf, which is equivalent to input or raw input in Python, and syntax is given as like int scanf of constant character and the format. So it basically has one or more arguments, like it has a statement along with the variable. So we need to get the input from the user by using the scanf. So the first format string for the address of variables that are going to be holding the values entered by the user, that will be the format. So printf, again, it has one or more arguments of the syntax that is shown, and the first argument is the format string. So the printf and scanf codes are given below. If it is D, it refers to integer. If it is O, it refers to the octal number. And if it is small x or capital X, it refers to the integer. And for printf, the capital X makes it use uppercase for the digits capital A, B, C, D, F. And the LD refers to long integer. So here the L can also be applied to any of the above to change the type from integer to long. And here we have U, L, U, C, S, F, and L. So U is unsigned integer, which is a decimal number. LU is unsigned long, which is again a decimal number. C is a character, which is the character. S is a character pointer. The format should be of string. F is float, that number with 6 digits of precision. LF is double, the number with 6 digits of precision. And how do you address a variable? So the address of variable can be obtained by putting a ampersand before the variable name. So that will get the address of that particular variable. So to perform the arithmetic operation between constants and variables, operands shall be either constant or variables. The variables can be of any type of integer or floating point, value or character, except for modulus operator. Modulus operator cannot be applied for floating point values, but can be applied for integer and character types. So modulus is nothing but like we need to find the remainder. We can use the modulus. This is the example, first example we are going to see. So we have integer a, integer b, and integer c. So integer a as 27, integer b as 25, integer c as an expression a minus b. So the output will be 2. In the second example, we are trying to find the modulus of a and b. So this is not allowed because the range here is only between 0 to 255. So in order to represent 273 modulus b, that's 25. So we represent 17 here. Here we use character instead of integer, that is character a, character b, and character c. So the output we get is a special character, and we are using %c here. In the previous case we used %d since it was an integer, but a and b were characters, so we got an error here. But in the case of third, we will be getting a special character. So the following are the operators which we use in C. So plus will add 2 operands, minus will subtract second operand from the first, and asterisk multiplies both operands, and division, it operator divides the numerator by the denominator, and the modulus operator will give the remainder, and the plus plus is an incremental operator which increases the integer value by 1, and the decrement operator decreases the integer value by 1. So we have the post increment operators and the pre-increment operators, and the parenthesis can be used to override the default precedence. So usually during the execution of an expression we see for the precedence, and the brackets we have the highest precedence. So the rule that is being followed here is 4 mass. So if you see this example, so we are declaring 3 variables a, b, and c. So a is equal to 4 and b is equal to 2, and we have expression c is equal to minus a plus minus minus b. It's a pre-decrement operator. So what output we get is, so instead of a we will be having the value 4, instead of b we will have the value 1, so the value will be minus 3. So if you see this second example, we have a post decrement being applied on b. So 3 minus 4 plus 2, so the output will be minus 2, and after the execution the value of b becomes 1. If you see the next example, so we are going to do a pre-increment and a post-increment in the same expression. So here the pre-increment will make the value of a as 5 plus. Next is we are going to do a post-increment. So it will be again 5 plus 5, so the value is 10. Because after the pre-increment the value of a will be 5. Next is we are doing the pre-increment and we are adding the variable a. So the first value will be 5, and next the value will become 6. So 5 plus 6, it will be 11. And I try to print the value of a, you will see a is 6. Okay, then a plus 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 a. We are doing a post increment and pre-increment again. So if you do that, you will get the value 10. Since the first value becomes initially it have 4, after which it becomes 5, and so we pre-increment 5 and becomes 6. So 4 plus 6, it becomes 10. So associativity of the operators in C. So when precedence of two operators are the same, then associativity of the operators is considered for evaluation. So if it is like the operator's parenthesis or square bracket or anything of the form, the associativity is from left to right. But if it is a plus plus or a minus minus or the similar ones, it is the associativity between from the right to the left. Similarly, you can see the other associativity as given below. And if you see the next slide, some of the things are referred to as like right to left, but most of them are from left to right. In this case, the ternary conditional is from right to left, and the assignment operator, the addition, subtraction, assignment, multiplication, division, assignment, and etc. are from right to left. So this is the partial code to execute the isogram column. So we declare the variables and we get the number of letters from the user, and then we try to print the number of letters, and then we go for the actual logic at the end. So compiling, as I told earlier, we have to give gcc programming.c. For printing, we should give ./a.out. We can do automatic type conversion in C. So convert a variable from one data type to another type, and the type conversion is performed automatically. The compiler, without programmer's intervention, that type of conversion is known as implicit type conversion or type conversion. So the compiler converts all operands into the data type of the largest byte. That is what is done usually. So these are the rules that are being followed. So sequence of rules that are being applied while evaluating equations are given below. All the short and the character are automatically converted to integer. Then if either of the operand is of long type long double, then others will be converted to long double, and the result will be long double. Else, if either of the operand is double, then others are converted to double. Else, if either of the operand is float, then others are converted to float. So rules for type conversion in C is like, else if either of the operand is unsigned long integer, then others will be converted to unsigned long integer. Else, if one of the operand is long int and the other is unsigned int, then if a long int can represent all values of an unsigned integer, the unsigned integer is converted to long int. Otherwise, both operands are converted to unsigned long integer. Else, if either operand is long integer, then the other will be converted into long integer. Else, if either operand is unsigned integer, then others will be converted to unsigned integer. So this is an example given. So here character A is 55, character B is 100. We say integer C is equal to A mod of B. So the ASCII representation of A and B are taken. So the output will be capital A, which is 65. So output will be capital A. Next is all the variables are of type integer. So you will be getting the output as 1. And in next example, we are going to give a float variable C. So we will be getting the output in form of float. And again here we are following the same float, but in this case, if you see, we have a float for B, but in the previous case we had an integer for B, so the output differs here. So here the explicit type conversion can be done by means of typecasting. So you can give the, if you see the last line, you can give the data type directly and you can do the typecasting. So as an example, you can give float in the bracket and A by B, so it converts that into a floating point. In the you can